Trigonometry applications, thus as I have said, T-ratios applications are widely used to measure the heights of objects or distances between them from any point on the ground or above the ground. If a person on the ground looks at the top of a tower, he frames an angle of elevation. At the same time, if another person looks down at the person on the ground from the same tower, he frames an angle of depression. Both angles are equal. Therefore, angle of elevation is equal to angle of depression. T ratios do have root 3 and root 2. Therefore, remember root 3 is equal to 1.732 and root 2 is equal to 1.414 for conversion factors. The problems concerning heights and distances always have angles of elevation or depression at 30 degrees, 45 degrees and 60 degrees. Neither 0 degree nor 90 degree will come. Therefore, you need to be thorough with the T ratios of these angles, and mostly they revolve around sine theta and tan theta angles. You can work these problems with sine theta and tan theta alone, since angle of elevation is equal to angle of depression. A boy 50 meters away from a water tank tower looks at the top of concrete pillars holding the tank at 30 degrees. He also looks at the top of water tank at an angle of elevation at 45 degrees. Find the height of the concrete pillars and also the height of the tank. Base length being available, we need to find the perpendicular height. T ratio corresponds to tan theta function. Tan theta is equal to perpendicular by base. Therefore, tan 30 is equal to BC by 50 meters, which is equal to 1 by root 3. Root 3 being 1.732. Root 3 BC is equal to 50. BC is equal to 50 by root 3. That gives us 28.87 meters concrete pillars height. Tan 45 is equal to 1. Therefore, BD by AB is equal to 1. BD by 50 is equal to 1. Therefore, BD is equal to 50 meters. Water tank height, therefore, DC is equal to BD minus BC, which is equal to 50 minus 28.87, which is equal to 21.13 meters. Concrete pillars height, thus 28.87 meters. Water tank depth, 21.13 meters. Now, an aeroplane flying at an altitude of 1500 meters finds two ships sailing towards it in the same direction. The angle of depression observed by the pilot of two ships at 60 degree and 30 degree respectively. Find the distance between those two ships. Let the distance between ship A and B be x and the distance AD is equal to y. Angle of depression to ship A from the plane is 60 degree. Angle of depression to ship B from the plane is 30 degree. Angle of depression is equal to angle of elevation. Ship B, angle of elevation to the plane 30 degree. Ship A, angle of elevation to the plane 60 degree. Since base and height are involved, it relates to tan theta function. Tan 30 is equal to 1 by root 3, which is equal to CD by x plus y. CD being 1500 meters, 1500 meter by x plus y. That gives us x plus y is equal to root 3 1500, equation 1. Tan 60 is equal to root 3, that is the 1500 by y. Y is equal to 1500 by root 3, that is equation 2. Therefore, the distance between two ships A and B is equal to x plus y minus y. X plus y being root 3 1500, y being 1500 by root 3, it gives us 1732.1 meters being the distance between two ships. Two boys are standing opposite to each other 200 meters apart and observe a plane flying above them. Boy A looks at an angle of elevation at 30 degree and boy B looks at it at 45 degree. Find the altitude of the plane flying above the ground above them. We are concerned with base and height, so it is tan theta function. Tan 45 is equal to 1, therefore CD height by BD is equal to 1. CD is equal to BD, which is equal to H, which is equation 1. By A, tan 30 degree is equal to 1 by root 3, therefore CD by AD is equal to Therefore, CD by AD is equal to 1 by root 3. Cross multiplying, AD is equal to root 3 CD equation 2. Now AD plus BD is equal to 200. That is root 3 CD plus CD, which is equal to 200 is equal to root 3 H plus H. Since CD is equal to H, that gives us H multiplied by root 3 plus 1 is equal to 200. Therefore, H is equal to 200 by root 3 plus 1. Rationalizing the denominator, we get 200 root 3 minus 1 by 2. That is 100 root 3 minus 1. Therefore, 100 into 1.732 minus 1, that is 100 into 0.732 is equal to 73.2 meters. Next problem, the angle of elevation to the top of a hill from the foot of the tower is 45 degree and the angle of elevation to the tower from the foot of the hill is 30 degree. Find the height of the hill and the distance between the hill and tower. Tower height is 40 meters. Perpendicular and base being involved, it is tan theta function. Tan theta is equal to tan 30 is equal to 1 by root 3, which is equal to AB by AC. Therefore, 40 by AC is equal to 1 by root 3. AC is equal to 40 root 3, which is equal to x. Tan 45 is equal to 1. Therefore, CD by AC is equal to 1. Therefore, CD is equal to AC. AC is equal to 40 root 3. That is 40 multiplied by 1.732 is equal to 69.28 meters. Therefore, the height of the hill and the distance between the tower and hill are the same at 69.28 meters. Next slide. The angle of elevation of a jet fighter plane from the ground is 60 degree. After 30 seconds, the angle of elevation changes to 30 degrees. The jet flies at a speed of 900 km per hour. Find the height at which the jet is flying. Now, look at the diagram. Let AC be x. The jet flies at a speed of 900 kmph and that in 30 seconds it covers a distance of 7500 meters, that is CD. Let BC is equal to ED being parallel equal to H. Tan 60 is equal to root 3 perpendicular by AC, BC by AC is equal to H by X. Therefore, root 3 is equal to H by X. H is equal to root 3x equation 1. Tan 30 is equal to 1 by root 3. ED by AD, which is equal to H by X plus 7500 is equal to 1 by root 3. Therefore, H is equal to X plus 7500 by root 3 equation 2. From equation 1 and 2, we get X plus 7500 by root 3 is equal to root 3x. Cross multiplying 3x is equal to x plus 7500, 2x is equal to 7500, x is equal to 3750. Height of the plane flying is root 3x, that is 3750 multiplied by 1.732, 6495 meters above the ground. In the next slide, an electrician repairs a pole of height 5 meters. He takes a ladder 1.2 meters below the top of the pole to have a better access. Find the length of the ladder if it is inclined to the pole at 60 degree. Electric pole height is 5 meters, that is CD is 5 meters. The ladder is inclined towards the pole at 60 degrees, that is 1.2 meters below the electric pole height. Therefore, BC is equal to 5 meters minus 1.2 meters, which is equal to 3.8 meters. The ladder is placed on the hypotenuse side. BC pole is perpendicular. Hypotenuse and perpendicular length involved. We have to choose a T ratio corresponding to them. Perpendicular by hypotenuse is equal to sine theta, which is equal to sine 60 degree is equal to root 3 by 2. Therefore, 3.8 by AB is equal to root 3 by 2. Root 3 AB is equal to 7.6 meters. AB is equal to 7.6 meter by root 3. Therefore, the ladder length is 4.387 meters. An aeroplane, while approaching an airport for landing, flies at an altitude of 1,300 meters. There is a river flowing adjacent to the airport runway. The pilot observes two banks of the river to his left and right at an angle of depression 45 degree and 60 degree respectively. He wants to find the width of the river before approaching the runway. What should be the width of the river to him? We are concerned with the height and base and therefore it is tan theta function. tan 45 degrees is equal to 1. Therefore, CD by BC is equal to 1. Therefore, CD is equal to BC, which is equal to 1300 meters. Tan 60 degrees is equal to root 3. Therefore, 1300 by AC, AC is equal to 1300 by root 3. Therefore, width of the river AC plus BC, which is equal to 1300 by root 3 plus 1300, which is equal to 1300 within bracket 1 by root 3 plus 1, or 1300 by 1.732 plus 1300, which is equal to 750.58 plus 1300, which the river width is 2050.58 meters.